Hi guys. In the previous session, we discussed about the PPIs. So the part one tells about to decide whether the PI driver needs to be dispatched or not. The part two talks about the notify events. The part three is talks about how to share the data between the two PI modules. So today we are going to see how to share the interfaces between the PI modules. Okay, so the interfaces meaning there is some particular task which is known to that PI module. So those functionality needs to be known to some other PI modules, right? So using the PPIs, we can share those interfaces. Okay, so let me open the EDK2 code. I'll go to downloads folder, EDK2 demo. I will open the VS code. Okay. So now this time we have to create a new header file because we are going to share the interfaces, right? So to share the interfaces between the two PI modules, there should be a common structure where both the drivers are going to access. Okay. So in my case, I will go to this emulator package and then I have the includes PPIs and here I'm going to create PPI part4.h. Okay. So this is going to have some license key. Okay, so license header. I'm just going to copy paste that. Okay, and then let's check whether with the same header file, do we have any other header files? If we have that other header file, then we don't have to provide our interfaces to them, right? So that time, so as you can see, so if it is not defined, then we are going to define it, meaning it will avoid inclusion of the different APIs with a different implementation. Okay, so if not defined underscore PPI part 4, right? If it is not defined, then we are going to define it. Okay, and we are going to end it. Okay, so if this is not defined anywhere, then we are going to define it and then we are going to add our stuff here. Okay, so what I'm going to do is simply I'm going to include one header file. Or maybe let's not do that here. Okay, so let's create a type def. Okay, so type def of a structure. Okay, the structure name we can keep the same common name underscore sample, or yeah, maybe we can create a structure called sample PPI underscore 4, which is going to have the structure name as the same name without underscore. Okay, so it's a forward declaration. Okay, so now this structure needs to be defined somewhere, right? So here I'm going to create a structure. Okay, so what is the structure name? Underscore sample PPI 4. Okay, so now here I'm going to add the interfaces which I'm going to expose. Okay, so to expose the interfaces, I should expose the function declarations, right? So in this case, let's say a type def. So I'm going to expose an header file or a function where it is not going to take any input arguments and it is not going to return anything. It's a simply void. So if I type in a regular C, it's a void some function, and that some function is not going to accept any arguments, right? Similar to this. Okay, so for this I'm going to create, right? So now, so type def. So type def, what I'm going to do here, so I'm going to add the function declaration, which is a void, and then EFI API just to maintain the compatibility between the GCC and the Microsoft compiler, and the function name, okay, or the interface name. So in this case, I'm going to say sample underscore PPI underscore interface underscore one. Okay, so this is going to be my interface name, okay, which is a type div, okay, and this interface is not going to take any arguments, which is a void. Okay, so what I did, so here it's a I'm just defining a variable. Okay, I'm defining a function, okay, which is a type which is going to return void, meaning nothing. And here I'm just mentioning the EFI API just to maintain the compatibility between the GCC and the Microsoft compiler. If you don't want, if you're sure that you're going to use your driver only in the Microsoft compiler, then you can free to remove this. Okay, and then this is going to be your interface declaration. Okay, so now for this declaration here, let's add the entry. Okay, so now this I will going to call this as a sample PPI interface one. Okay, so now here what I'm going to do is I'm just going to add some description about this function. Okay, so interface for some experiment. Okay, so now where this is defined, so this is defined here. Okay, so now our header file simply looks like this. Okay, so now here you can add your own description however you wanted. Okay, so which is out of my scope, out of this video scope. Okay, then uh, we have to create, so since we are going to expose the interfaces, right? So this interface should be tied with a PPI. Okay, so meaning we have to create one PPI here. Okay, so if I go back to this simulator package.dec, here we have these PPI sections. Let's create one PPI here. Control Shift P, insert GUID, and then choose the option number 3. Okay, so when you're pressing Control Shift P and if you're not seeing this insert GUID option, so just go to this extensions and install this insert GUID. Okay, so now let's write our interface name. Okay, so G PI sample. What is this name? Sample PPI 4. Okay, so sample PPI 4 GUID. Okay, so let's make the alignments. It's just a beautification and code clean. Okay, so I will make this as a uppercase, Control Shift P, and transform to uppercase. Okay, so in the DC file, we have our PPI, which is associated with this GUID. Okay, and we are going to tie this PPI with these interfaces, which in our case, it's a null interface, right? So now this is a function name, and this function name just we have defined it, but what this function is going to do, so that is a producer responsibility. Okay, so then in this case, what I'm going to do is we have to decide a driver. Okay, so who is going to provide the functionality to this interface. Okay, so in this case, so probably let's decide maybe this firmware volume PI as an example we can take, right? So I will go back to this, and here I'm going to include that header file. Okay, the header which we have created now. So this is a part of emulator package include PPI and then PPI part 4. So we have to include this path. But if I go to this C file and the INF file, we have already included this emulator package.dec. If I go to this DEC file, so we have this include sections, right? So now this includes is going to include one folder called include, right? Meaning it's a emulator package slash include. And then, so whatever the path after this include, we can use directly. Okay, so in this case, this emulator package is coming from the DEC file, and then the include path, it is coming from this include, which is present in this section header called includes, and then PPI slash our header file name. Okay, So hash include PPI and then our header file name PPI part 4. Perfect, right? So now let me close the other tabs. So here we have a function called the sample PPI interface, right? So let's create the function definition for this. Okay. So now the function definition should be looks like declaration is a void as a return and the void as an input. Okay. So void the function name, and this function is not going to take any arguments, right? And then open bracket, and then for now let's try to print some debug message. Okay, debug underscore info. So bios some keyword, and then I will say called slash n. Okay, and then probably I can define some uint 32 as a data, and then data I'm going to assign with some value dead, and the same data I can print here. Okay, so if your interface is going to return this data, yes, you can return 0x percentage x, and then the argument is data. Okay, so now what we did in this C file. So this we are going to assume this as a producer. Okay, so he's going to produce the interfaces. Okay, so we have this function name. So where this function name it is coming from? This is coming from here. Okay, and the declaration of this should looks like this. So, okay, so the similar declaration we have added here, and for this declaration we have added the definition. Okay, so now how can we tie this function to this structure, right? So for that, so I'm going to create the another structure pointer here. So in this case, this is our structure which is pointing to this sample PPI 4. Okay, so sample PPI 4. Okay, so I'm going to create the PPI out of it. Sample PPI 4. Okay, and this sample PPI 4, this is a function. It's a structure, right? So this structure is going to have one entry, which is this function pointer, right? So I'm just going to mention this is a function, so I'm just going to add this function here. Okay, and then it ends with semicolon, right? And then so I got my interface ready. So this interface is going to tie with this function. Okay, so now this interface I have to tie it to one of the PPI events, right? So I have to create the PPI descriptor. Okay, so how can I create? So if you saw my previous videos, you can see it should similar looks like similar to this EFI PI and then PPI underscore descriptor. Okay, and the descriptor name we can create this as a M sample PPI 4. Okay, and so for this, the first argument is what is the type of the PPI which we are going to create. Okay, so in this case, so since we are going to expose the interfaces, so it's a type of the descriptor. Okay, so EFI PI PPI descriptor PPI. Okay, and it should have the null terminator list. Okay, so EFI PI and then descriptor terminator list. Okay, so this is the first argument. And the second argument, we have to tie this PPI with a GUID. So it's the address of ampersand. So we have to provide the GUID name. So in this case, the GUID which we have created is this one. I'm going to add this GUID here. Okay. So now, so how this module is going to know what is the definition of this GUID? So in this firmware PI, so I'm going to add this GUID in these PPI sections. Okay, So now this PPI, we are producing it just for readability. I'm going to mention as a producers. Okay. So now we specified what is the type of the PPI which we are creating, and that PPI is associated with which GUID, that also we specified. And then, so what is the let's see, what is the third argument of this? So flags done, GUID is done, and we have to provide the pointer to the PPI. Okay. So in our case, it's a white pointer we are going to give. So white star. Okay. And we are going to provide the address of the PPI the structure which we have created above, which is sample PPI4, which is coming from here. Okay. So I'm going to give, and then it ends with this semicolon. Okay. So let me rewind. Okay. So if I look at the changes, I just created the PPI GUID in the PPI section of the DC file. And then I created a header file. So that header file is going to have a structure. So that structure is having one type def, which is the sample PPI interface. Okay. And then I went to the C file, and then I created a function which is matching with this type def. Okay. And then for that I have added the functionality. So in this case, I'm going to print some sample message and I'm going to print some data. In your case, you can add whatever the functionality which is needed for your use case. Okay, so then I created a variable of a type this sample PPI4 structure. Okay, and that structure name, and it is going to have one member, right? So that one member I have specified here. And then so I created a descriptor PPI which is having the flag as a PPI descriptor PPI, and then I specified the GUID, and then so what is the pointer to this PPI, right? So that pointer is this one, sample for PPI, sample PPI 4. Okay, so now with this our PPI is ready. So now we have to install it. Okay, so how can we install? So if you rewind our previous videos, right? So we have to use a function called PI service install PPI. Okay, so let me install after this debug message, right? So PI services install PPI. Okay, so then I'm going to provide the address of the descriptor. Okay, so now with this, at least the build should happen and the PPI should be installed. I will open the command prompt here, and then I will type EDK setup. Let's see whether the build is going to happen or not. Okay, so setup is done. So I'm going to build. Okay, so let's wait for a moment. Okay, so yeah, looks like still no issues observed. Still no. Okay, yeah, so looks like its biases got generated, and here you can see it's a success. I'm going to open the command prompt in the build folder, emulator IO32, VS19, IO32. So here we have our WinHost, right? So I'm going to open the command prompt here, WinHost, redirect to boot.log and redirect everything. Okay, so it is already booted to UEFI shell. Let's close this. So let's open the boot.log which we have created. Okay, boot firmware, not the firmware, IO32, and here we have our boot.log. Okay, and so this is our firmware volume PA, right? So here you can see after this Unix, let me open that C file as well. So this is, yeah, so this is our debug message. As soon as our debug message is completed, so we are going to install that PPI, and we have some other notify events, right? So the similar you can see after this debug message, we have our install PPI. Okay, so after this install PPI, so meaning, so this will give you evidence that our PPI is getting installed. Okay, and it is exposing an interface called this one interface. Okay, so now let's try to consume this interface in some other driver. Okay. So how can we consume this interface in other driver? So let's say I'm going to use maybe this PA sample driver. Okay. So in this, I will go to the C file. Okay. So I will going to include the interface header file which we had created. So hash include PPI. What is the header file which we have created? It's a PPI4. Okay. .h. Okay. And this is going to expose a GUID, which is this one. Okay. So now we have to reference this GUID for this driver as well. I will go to this TC file, INF file, sorry. And then in the PPI section, I'm going to use this. And then I'll mark this as consumed. Okay, so now this driver knows what is this GUID declaration of this GUID. Okay, and then I just included this header file. So we have our driver, right? So here, let me. So we are going to expose the interface, right? So what is the interface we are going to expose? So that is the type of this structure. Okay, so that structure pointer, let's create that. Okay, so it's a structure. So let me create a pointer sample PPI4. Okay, so let me make some alignments. Okay, so now this pointer should assign with some variable with some address, right? So how we are going to do? So maybe after this value which we are printing, so let's assign that. Okay, so I'm going to say status is equal to PI service locate PPI. Okay, so for this locate PPI, the first argument is I have to locate what? I have to locate an interface. So how that interface is going to be located? With the help of the GUID. So I have to provide the GUID name. Okay, so the GUID name, it is coming from here. So I'm going to provide the address of the GUID and then the zero flag and then the null pointer. And then, so once that interface is located, to which address I have to store the data, right? Right. So which is the pointer which we have created, which is this sample PPI4, which is a type of the void pointer. Okay. So void star star and then the address of this. Okay, and it ends with a semicolon. Okay, yep. So now let's see whether first what we are going to see is whether the status, whether it is success or not, meaning this driver, whether it is able to locate this interface or not. First we will see and then we will call. Okay, so debug underscore info BIOS and then I'm just using this GUID name. Status is equal to %r/n and then status. Okay, so let me build it. Okay, so meanwhile it built. So what we have did, so we have added that PPI in the INF file and then we imported that interface, which is a PPI part 4, and then we created a pointer of that structure, and that structure pointer is going to assign with a void pointer which is coming from this PI service locate PPI. So this locate PPI, so we are going to pass the argument as the GUID name here. Okay, so let's see. So here you can see the BIOS got builded. So let's try to run command prompt winhost boot.log redirect everything. Okay, so it got booted. Okay, so let's look at the boot.log. Okay, so now let's search for this debug message, right? So this one. So here you can see success. Okay, so meaning it can able to successfully locate that PPI. Okay, so now let's try to call that interface. Okay, so how we can call? So sample PPI force. followed by the arrow key, and then the interface name, which is not going to take any arguments. Simple. Okay. So it's an interface, which is a pointer, and that pointer is pointing to the structure. So that structure variable name, right, which is a sample PPI interface one. So now I'm going to run build. Okay, let's wait. Yeah, so build is done. CMD winhost boot.log, redirect everything. Okay, so it is already booted to UEFI shell. Let's close this. Let's look at the logs. So here you can see our status is success, and then we are calling our interface, which is that what that interface is doing. So that interface is printing some sample message, and it is printing some data. So actually, where this data is coming from, this data, it is coming from this firmware volume PI, okay, by this function, right? And as you can see, this is not the library, but rather than it's a driver, right? So it has a driver of a type PIM, which is as the entry point of this one, right? So meaning, so this driver is going to expose this one interface, okay? So this interface is going to tied with this PPI GUID, and that PPI GUID is located by this driver, and it is calling that PPI interface. Okay, so in the next video, what we are going to do is we will try to add some more interfaces to the same interface which we had already created here, right? Which is this sample PPI 4. Okay, so that's it for today. Thank you.